Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic solutions and this is part 5 of the chapter. This is for class 12 CBSE. Today we will see vapor pressure of liquid solutions. Now if there is a binary solution of two volatile liquids and we name the two components as 1 and 2, and if we take them in a closed vessel, both the components will vaporize. And when they vaporize, there will be a vapor phase and a liquid phase, and we find that there will be an equilibrium between the vapor phase and the liquid phase. Now since there are two components, there will be a total vapor pressure that is represented as P total, and the partial vapor pressures of each of the two components will be represented as P1 and P2. And these partial pressures are also related to the mole fractions x1 and x2. Now see, related to all these, there is a law, that is Raoult's law. Raoult's law states that if there is a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in the solution. So mole fraction means out of the total number of moles, how many moles of that particular component is present. This mole fraction is proportional to partial vapor pressure of each component, or in other words we can say that the partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in the solution. Now see, for component 1, we represent the partial vapor pressure as P1 and the mole fraction as x1. So P1 is directly proportional to x1. To remove the proportionality sign, we can write P1 is equal to P1 naught x1. Similarly, for component 2, P2 will be equal to P2 naught x2. P2 is equal to P2 naught x2. Now here we can apply Dalton's law of partial pressures. According to Dalton's law of partial pressures, the total pressure P total is equal to P1 plus P2. But we know that P1 is equal to x1 P1 naught. P2 is equal to x2 P2 naught. But also x1 can be written as 1 minus x2. Instead of x1, we can write it as 1 minus x2. x1 is 1 minus x2, that we put up here. Rest things will be same, P1 naught will come plus x2 into P2 naught. On opening the bracket, P1 into 1 is P1, P1 naught into 1 is P1 naught, minus x2 into P1 naught is x2 P1 naught with a minus sign which will come here, plus x2 P2 naught. Now say P1 naught will be written as it is. In this 2, we can take x2 common. So it is P2 naught minus P1 naught into x2. This is what we get here. Now from this equation we can conclude that the total vapor pressure over the solution can be related to the mole fraction of any component, because here we get only x2. So mole fraction of any component. Mole fraction of any component. Next we conclude that total vapor pressure over the solution varies linearly with the mole fraction of any component. And finally, depending on the vapor pressure of the pure components 1 and 2, total vapor pressure of the solution will either decrease or increase with the increase of mole fraction of either component. Okay. Depending on the vapor pressures of the pure components 1 and 2, total vapor pressure over the solution either decreases or increases with the increase of the mole fraction of either component, that is 1 or 2. Okay. So I hope you all could understand till here. Now let us solve one numerical. It is given that vapor pressure of chloroform and dichloromethane at 298 K are 200 mm mercury and 415 mm mercury respectively. Calculate the vapor pressure of the solution prepared by mixing 25.5 gram of chloroform and 40 gram of dichloromethane at 298 K at the same temperature. So first of all, we have to find the moles. To find the moles of each component, we need to find molar mass. First, molar mass of dichloromethane CH2Cl2. Molar mass of CH2Cl2, this is 12 into 1 carbon plus 1 into 2, 2 chlorine. So 35.5 into 2, on calculating an addition after this we get 85 grams per mole. Next, molar mass of CHCl3, 12 into 1 plus 1 into 1, 35.5 into 3. We get it as 119.5 gram per mole. Now number of moles. Moles of CH2Cl2, given amount 40 divided by 85 gram per mole. It will be 0.47 mole. Next, moles of CHCl3, given amount 25.5 divided by 119.5 gram per mole, that you got the molar mass. This is 0.213 mole. Total number of moles. Zero point four seven we got plus 0.213, 0.683 moles. Now mole fraction. First one for CH2Cl2, 0.47 divided by 0.683. 0.688. For CHCl3, 1 minus 0.688, 0.312. So we got both the values of mole fractions. Now we know that P total is equal to P1 naught plus P2 naught minus P1 naught into X2. So P1 naught was given as 200 it is given 200 millimeter. P1 naught is 200. So it becomes this equal to 200 plus P2 naught is 415 minus 200 into x2. x2 is 0.688. 0.688. This is equal to 200 plus 147.9. This is equal to 347.9 millimeter mercury. So the final answer is 347.9 millimeter mercury. So students, I hope that you all could understand the topic I discussed today along with the numerical. Thanks for watching my video. Please subscribe to the channel. Thank you.